let's continue our notes. That last number was actually something really special. That last number, p to the 0 power, is something special. This is called the zero exponent property. Any non-zero number raised to a power of 0 will equal to 1. Anytime you have a number and it's raised to a 0 or a variable, it could be a number raised to 0 power or a variable raised to the 0 power. It doesn't matter. Anything raised to the power of 0 is going to be the number 1. So what would happen if you have 0 to the power of 0? Well, if you look back up here, it says any non-zero number raised to the power of 0 will be equal to 1. So this is 0, which means it doesn't match this rule. So what's going to happen? 0 means nothing. If you have nothing and you raise it to the 0 power, it's not going to make the number 1. If you have nothing in your hands and you raise it to an exponent of 0, you're still going to have nothing. So 0 to the 0 power is still 0, but every other number, anything else raised to the power of 0 is going to make 1. So you need to write this fact down, the definition, and what it's called. I want you to use a calculator and put these numbers in there. 2 to the negative 1 power, 10 to the negative 1 power, 2 to the negative 2, 10 to the negative 3. You better be putting this on your calculator on your own. You need the practice. I can do all this stuff in my head, but I'm doing it for your benefit in the video. And the answers we get are, so notice, we started with something, a regular number raised to a negative power. Normally, whenever we put something to a power, it makes a larger number. But notice that whenever this exponent is negative, it made a smaller number. You started with 10, now you have 0.1. Started with 2, now you have 0.25. It shrunk. So there's something going on that's shrinking these numbers. Did you notice anything suspicious about these answers? If you didn't notice anything suspicious, go ahead and take yourself to Google and convert these numbers into fractions. So let's see if we can have Google search convert these answers into fractions. 0.5 as a fraction, thank you Google, is 1/2. So in your notes, where you already wrote what it was equal to, just go ahead and put another equal sign and say that this was equal to 1/2. This one was equal to 0.1, which as a fraction is 1/10. And put the fractions of the other two. Come on, just go back to Google. Pause the video, go to Google, type whatever the decimal is as a fraction, it'll tell you what it is. Okay, now let's come up with a name for what happened. And that's called the negative exponent property. And what happens is, any non-zero value, so just like before, 0 doesn't apply here, but if it's anything else raised to a negative exponent, that value will equal to the reciprocal value raised to the positive exponent. So something raised to a negative power is equal to the reciprocal, so that's the flipped version, raised to the positive exponent. Let's get an example. 1 divided by x to the negative 3rd power. This will be equal to the reciprocal. So that means we're going to flip that fraction over, and we're going to raise it to the positive exponent. So we flip it and change the exponent to be positive. And then, if we're just dividing by 1 now, we can simplify that to be x cubed. When you're dividing by 1, it's not going to change it at all. Let's do another example. A regular old h to the negative 4 power. H to the power of negative 4. this will be equal to the reciprocal. So we're going to take this and turn it into a fraction, and we're going to change the power. It wasn't a fraction, now we had to make it a fraction. The only way we make it a fraction without changing anything is if we use the number 1. So that's why the 1s happened, is because whenever you want to change something into a fraction, you're going to either divide by 1 or do 1 divided by that thing whenever you're doing the reciprocal. So you change it into a fraction, and you change the exponent from negative to positive. Go ahead and try these. I'll do a few of them with you as an example. The rest you need to do as an example on your own that you figured out yourself. So we're going to change this. It's not a fraction, so we need to make it into a fraction and make it a positive power. You can only change the sign of the power whenever you change the way the numbers showed up. So these two will work exactly the same as that one. This one, it's already a fraction, so we're going to flip that fraction, and we're going to change the power to be a positive. And the only time you change the power to be positive or negative is whenever you flip it across the fraction. Here, 5 to the 5th power is going to stay. 5 to the negative 2 power, this is going to change to become 5 squared over 1. Let me show that over here. 5 to the 5th over 5 to the negative 2 is equal to, I'm going to expand this. This is equal to 5 to the 5th times this number is being divided by this number. So that's the same thing as multiplying by the fraction. If we split this apart, this 5 to the negative 2, 5 to the power of negative 2 is going to stay on the bottom, but we're just splitting the numbers apart so that the numerator is multiplying the other portion as a fraction. This is just splitting a fraction apart. If you multiply these parts, this would multiply with the 1, and it would make you back to that. Then, to get rid of the negative exponent here, we can keep this first part the same, and then you will flip 5 to the negative 2 to be 5 to the power of 2 over 1. And now that you have a 5 with the positive power and a 5 with the positive power, you can do 5 to the 5th times 5 squared, which makes 5 to the 7th power. To go through this one a little tiny bit quicker, the negative power is going to change its position. The positive power is going to stay where it's at. So this 6 to the negative 12, when you put it on the denominator, it's going to be a positive 12. 6 to the 8th is going to stay where it's at, and we need to put a placeholder number 1. Now that these are both positive powers, you can combine them together. 1 over 6 to the 12 plus 8, which is 1 over 6 to the 20th power. To stretch a little bit further, if we have 4 times n to the 5th power and 4 times n to the negative 5th power, are these two things reciprocals? Are they equivalent, just flipped? 4n to the 5th, 4n to the negative 5th. How do you change this power to be positive? This power is applying to the letter n. So that's going to be 4 times 1 over n to the 5th. And what does this make when you multiply these two things? 4 times 1 over n to the 5th. This 4 is going to multiply the 1, and that's going to make 4 over n to the 5th power. Whereas over here, we just have 4 times n to the 5th power. So are these things straight reciprocals? Is this the flipped version of this? The completely flipped version? No, it's not. When we use the order of operations, we have to separate this 4 from that n being raised to a negative power. But here, on the left side, if we did the reciprocal of 4 times n to the 5th, the actual reciprocal, that would be 1 over 4 times n to the 5th power. So this is the true reciprocal. This is not. It's only like halfway the reciprocal. Okay, so that's the end of today's notes. The purpose of today's notes. Let's go back and see if we answered our objectives. The objective was, come up with the rule for dividing monomials. If we have x to the 5th divided by x to the 4th, do you know what to do with that? The two options are, you expand it and then cross things out, or you take the exponents and the top number will subtract the bottom number to get x. And that's what was left over here, was x. The other one was to find a way to deal with negative exponents. If you have x to the negative 2, you should know now that that's equal to x squared, but the flipped version of that. Or x to the negative 8 divided by x cubed is going to have the positive power stays, the negative power is going to join it on the other side of the fraction. And then once they're both on the bottom, then you can multiply them, which means you will add these exponents together. 1 over x to the 11th power. Okay, I hope this video was helpful for you. Your assignment shouldn't be that bad after looking at these examples, and if you do understand how to complete these two objectives. Good luck.